Hey everyone, today we are going to begin section 3.2 and we're going to be talking about variation. In the previous few videos, we talked about measures of central tendency, which are basically just averages, like mean, median, and mode. And today we're going to begin talking about a variation, which means sort of the difference between values, how spread out the value is. So just to begin, I found this picture online and it was pretty interesting. You can see all these different body types here, right? And the article that goes along with this picture, it actually says, it makes the claim that genetics only account for 10% of your variation in height, which I found a little bit hard to believe, but it does give some evidence for that. So it's saying that environmental factors along with your genetics account for the other 90% of your height and just overall body type as well. So take with it when you will. You guess you can't blame your parents if you're too short because they're only responsible for 10% of that. So anyhow, thought that was interesting. So we are going to be talking about range, which is probably the one measure of variation that you have seen in your life. And then we're also going to talk about variance and standard deviation. So let's start by just defining range. Range, if you remember back in the day, you learned probably along with mean, median, and mode. Range is just the difference between the largest number and the smallest number in distribution. Just do the biggest one minus the smallest one. Kind of as I stated, it's not really a great way to measure variation. The reason why is it doesn't actually tell you anything about all of the data in the middle. All it's doing is comparing the biggest one to the smallest one, but it doesn't tell you if all of the data in the middle is really close to the high one or really close to the low one, or if it's all evenly distributed throughout, or if it's all concentrated in the middle. It doesn't tell you anything about all of that data. So it's not really a great way to measure this variation. Fortunately, there's a couple other ways to measure variation a little bit better. And that is variance. Variance is just a measure of the variability of a distribution. And we'll talk more about what this actually tells us. And standard deviation essentially is measuring the same thing. However, standard deviation is just the square root of the variance. So this is the more oftenly used one, standard deviation. They're essentially the same thing, except you just got to do one extra step to calculate standard deviation. The symbols we're going to use for these two terms here, variance, we're going to use s squared if we're talking about a sample, and we're going to use a lowercase sigma squared if we're talking about a population. So if we're just talking about a small sample, we're going to use s squared. And if we're talking about an entire population, we're going to use sigma squared, and that's the lowercase sigma. If we're talking about standard deviation, we're just going to use the letter s for a sample. So you can see there it's just the square root of the variance. Or you could also say the variance is just the standard deviation squared. And then for a population standard deviation, we're going to use just sigma. And the formula just changes slightly if you're talking about a sample versus the population. So standard deviation is the more commonly used measure, more so than variance. I'm going to have you identify both, but as you'll see later on in this section, standard deviation is the one that's commonly used. It's a smaller number that is more meaningful, and we're going to talk about a lot of the practical uses of that standard deviation as we progress. This you can think of as showing the distance from the mean. So if it's 12, you could say that eventually we're going to use a theorem that says, well, if the standard deviation is 12, then approximately like 64% of the data is within 12 of the mean. So within adding 12 or subtracting 12 of the mean, you could say that 64% of the data values are in there. So again, we'll talk about that in the days to come. For right now, we're just going to be doing these computations. So we're going to need some formulas if we're going to do some computations. So for variance, S squared, it's going to look a little bit intimidating. It's going to be capital sigma. Remember, that means the sum of, and then it's going to be x minus x bar squared over n minus 1. So that is for a sample. And that's what we'll be using today. We're just going to be looking at samples. If it was a population, so if it was sigma squared, the only difference is on the denominator. We're still doing the sum of x minus x bar squared over, and we're just going to use big N. Big N represents the population size. This is for population. The little n just represents the sample size. Okay, so that's variance. So the standard deviation is the same thing, except we just take the square root. So for S, it's going to be the square root of the top one up there. The sum of x minus x bar squared over n minus 1. And sigma, it's going to be the square root of the sum of x minus x bar squared over n. So again, a sample versus a population. If you need to pause for a second and write those down, go ahead and do so. All right, so what does this mean? Well, the x in this represents all of the individual data values. So let me write a little bit more description out here. So the x's in these represent each data value. So we're going to do each data value minus x bar. And if you remember from the previous video, x bar represents the mean. So you actually have to do a calculation to find the mean in all these problems as well. So you're going to do each data value minus the mean, square it, and then you got to do this for every single data value. You're going to add them all up together. So that's what the sum of. So it means the sum of all of the data values minus the mean squared divided by, and then n is either the sample size for little n or big N is the population size. So the only thing that changes is you just do a minus 1 if it is a sample, and you don't do the minus 1 on the denominator if it's population. You might still be a little confused. It's perfectly fine. We're going to go through and do several examples on how to do this. So our first one, we're going to be looking at some election results today. And not necessarily looking at the whole picture, but looking at some individual pictures. So we're going to compute the range, variance, and standard deviation. And what we want to try to figure out is how much variation was there in the presidential election between the 5 largest cities in America. So if we were to take the 5 largest cities, typically we think of large cities as very democratic. That's been the case for a long time. Large cities like New York City, LA, Chicago, those are very democratic cities. And also part of the reason why we have an electoral college is so those large cities don't outweigh all of the smaller states like the North Dakotas and Colorados and Hawaii's and all those. They still get some say. So we're going to look at the 5 largest cities, and the site I'm using here is on Politico. It shows you the breakdown of all the states as they've been called so far. So if I were to click on, let's just say, let's do the California one, and it will break it down by county. Sorry, here. You can go look at individual counties. See Joe Biden won California and LA down here. So the county in which LA is in, LA County, Biden got 71% approximately of the vote. Trump got approximately 27%. So you can see a very democratic there. If we were to look at a different state, let's say Houston in Texas, that's one of the largest cities in the United States as well. Trump won Texas, and Houston, right here, that is Harris County. So it looks like Biden won approximately 56% of the vote in Harris County. So what I did is I went through and wrote all those down here. This is the percentage of the vote that Biden got in those top 5 cities. And you can see that he actually won all of those. New York City, he got 74% of the vote in that county. LA, 71%. Chicago, 56%. Houston, 56%. And then Phoenix, Arizona, he got 50% of the vote. So Biden actually won all of the large major cities in the U.S., the 5 largest at least. So what we're going to do is figure out what is the range, the variance, and the standard deviation given these 5 data values. So the first thing that we have to do when we're doing a variance and standard deviation, let's go ahead and do the range first. It's the easy one. So the range, we're just going to do the largest minus the smallest. 74 minus 50, 24. All right. Now, in order to do the standard deviation and the variance, if you remember in the formula, the mean is actually in there, right? X bar. So we actually have to do that first. So let's go ahead and get X bar. For that, we just add them all up and divide by the number of data values. 74 plus 71 plus 56 plus 56 plus 50. So we did this before. And when we do that, we get 61.4. And now we're going to use that in our other calculations. So we're going to just do S in all of these in the sample as opposed to the population, because we're just considering the 5 largest cities. We're not considering all of the cities in America. So we're going to do S squared for variance. Now we're going to set this up is we're going to do each data value. So I'm going to start with 74 minus the mean X bar. So minus 61.4. I'm going to put it in parentheses and square it. Okay, this is the sum of the X minus X bar squared. Okay, so that's where that's coming from. Now the sum of part means we need to be adding some together. So we're going to do plus, and then we're going to do our next value. 71 minus 61.4 squared. And then plus 56 minus 61.4 squared. Plus 56 minus 61.4 squared. And plus 50 minus 61.4 squared. Over n minus 1. N represents the population size. So there's 5 data values. It's over 5 minus 1. So we're just going to type all this into the calculator. I would do the whole denominator just in one time into your calculator, in your graph calculator. Hopefully you've got that. Just type it all in exactly how I have it written. Parentheses, number minus the other one. Make sure you square it. It's easy to forget that square. And then plus the next one in parentheses. So do all of the numerator and then hit equals. You should get approximately 439.2. And then 5 minus 1, which is 4. So make sure you write that step so I can at least see where you messed up maybe if you didn't get this step correct. And then 439.2 divided by 4 is 109.8. So that is S squared. Now all we have to do to find the standard deviation, S, is just take the square root. So S is just the square root of 109.8. And that is 10.48. So those are my 3 answers there. This was the variance, and this is standard deviation. Again, at this point, you don't really have an understanding of what these mean. We will be using them in the days to come. But just kind of a primer, what we're going to be doing is taking the mean and adding and subtracting multiples of the standard deviation. And that tells us information about how much of the data we could expect within an interval. All right, so let's look at another example. And this one we'll look at actually some more local results. If we're to look at the local counties surrounding Licking County, So as you do know, Trump won Ohio, but if we were to take a look more locally, let's see what happened here. Let's switch to Ohio. So here we are in Licking County. Trump got 63% of the vote in Licking County and Biden got 35%. And you can see actually most of the counties around us were red as well. However, Franklin County, which is where Columbus is very blue. It's 65%, so almost the complete opposite of Licking County. As I said before, a lot of the major cities you'll find are typically vote Democratic. And as you can see is the case here with Ohio, we've got Cleveland, Akron, Toledo, Dayton, Cincinnati, and Columbus. The 6 major cities in Ohio all went in favor of Biden. So that is generally the trend throughout most of our country's history. Rural places tend to vote more Republican. This doesn't always hold true, but typically does. So considering we live in Licking County, what we're going to do is figure out how much variation there is in the counties, Licking County and the ones surrounding it. So what I did is I went to all of the counties touching it. So Knox County, Delaware County, you can see it's pretty close there. Franklin County, Fairfield County, Perry County, Muskingum, and Coshocton County. And recorded all of those, which we have here. And we're going to figure out what is the variance between these counties. So sort of what's the spread of this data. Now you might expect it to be a little bit higher probably before we even start because there is this 134 here, right? We've got up into the 70s. And then since we're including Franklin County, that only went 34% Trump. So that will give us probably a lot more variability than Biden did when we looked at the major cities. We had some in the 70s, but the lowest we went down to was 50. So you would expect probably a higher standard deviation in this because it's going to be more variability. So let's go ahead and do that calculation. Let's start with the range. Range is the biggest minus the smallest. So our biggest was 73 minus our smallest of 34. And for that, we should get, 39. When we are going to now calculate our variance, we first need the mean, x bar. So we're going to add them all up. You guys should be able to do that by now. You get you 498 divided by the sample size of 8, so 62.25. Now, calculating our variance, s squared first, we're going to do each value minus this mean. So 63 minus 62.25 squared. And then we got to add the next one, plus 69 minus 62.25 squared plus, and then I'm just going to do just a little bit of different notation here. I'm going to skip some of the middle ones. We know what's going to be happening here, and we do need to type all these into your calculator when you actually do it. But this is just some notation to show what I'm doing, all the way down to 74. So 74 minus 62.25. Often you'll see this notation in math, just so you don't have to write everything out. But again, you do need to type all of these into your calculator, each one minus 62.25 squared plus the next one. All right, so we're adding all those up. That's the sum of all of them divided by the total number in the sample, which is 8. So it's 8 minus 1. When we do that, we get s squared equals 1261.5 over 7. And that gives us 180.21 approximately. And then for s, standard deviation, we'll just take the square root of that, 180.21, which is 13.42. So you can see if we compare it to the last one. So this is variance. This is standard deviation. If we compare it to the last one with Biden, standard deviation and variance were both higher in this one, which again, what we would expect. In the last one, it was 109 and 10.4. This one was 180 and 13. So definitely more variation in this one, which again, we would expect because we got a 34 and a 73. And also you can see that the range was significantly higher as well. So by any measure, there's a lot more variability in the just local feelings as compared to national big cities. All right, last example we'll look at. This one, I want you guys to do most of this one. See how well you're doing. So here's just some weights of some random football players. We've got everything from maybe a receiver or something like that down here at 190, up to some big linemen, some 350, 324-pound linemen on the team. So we just took a random sample of some of the members of the team, and we're going to find the range, variance, and standard deviation. So go ahead and calculate the range. Range on this one will be 350 minus 190. So that's going to give you a 60. Next thing you do is calculate the mean. So go ahead and do that. Your mean for this one should be approximately 262.38, which means we can now go ahead and set up the variance. So S squared is going to be 202 minus 262.38 squared, don't forget the squared part, plus 324 minus 262.38 squared. And then again, you're going to type all of these in. We're going to end up at 350 minus 262.38 squared divided by 8 minus 1. So go ahead and do this calculation. Type this into your calculator well, and make sure you're checking your work. So for S squared, we end up with 45016.51 divided by 7, which is 6,430.93. And lastly, go ahead and calculate the standard deviation using this number. So S is the square root of this, which is 80.19. All right, now these numbers are a lot higher than on the previous data, but we can't really compare these because, well, the numbers in general are a lot higher. We're talking about weights, which are 3-digit numbers, as compared to just pole numbers, which were 2-digit numbers. So we would expect a lot more variance and standard deviation in this because there's a lot more, just variation in the overall weights of these football players. 350 to a lineman down to a wide receiver, something like that. You would expect a lot more variation within these results. So key things to remember when you're doing this: don't forget the squared symbols when you're typing these all in. Make sure you use parentheses. Take your time, check your work, and good luck.